All right, what we've got here is a little less common of a problem, but one that comes up enough that I thought, let's go over an example of it. This is one that involves trigonometry. So you watch a hot air balloon rises vertically above your school. So you got the hot air balloon, let's just kind of draw a picture here. Whoop, going like this, there it goes up, right? You set a camera on the ground 500 feet horizontally away from the balloon. So that's constant. So in my drawing, I'm going to draw on the 500 feet constant. It's not changing. The camera tilts its line of sight to track the balloon at a rate of 0.4 radians per minute. So you've got basically a line of sight that is changing, right? It's arcing up like this. So I'll call that angle theta because it's changing, and I'll call this value h because that height of the balloon is changing. But the distance the camera is from the balloon rising is not changing, so that's why it's 500. Now, what is the rate at which the balloon is rising when the camera's angle with respect to the ground is pi/4 radians? So we've got to relate the changing values here. We've got h, a 500, and a theta. We could use tangent theta. So we've got tangent of theta is equal to the opposite over the adjacent. Oh, using some trigonometry here. Nice. So now from here, what we're going to do is we're going to solve, if we can, for the variable that we are going to want to take the derivative of. So we want to know the rate at which the balloon is rising. That would be the dh dt. So I'm going to multiply both sides by 500 just because taking the derivative will be slightly easier. Not much, but slightly easier doing that. Okay, let's take a derivative. We're looking on both sides. The derivative won't be so bad to take. We'll take the derivative with respect to time. 500 is just hanging out there. The derivative of tangent of theta is secant squared theta times the derivative of theta is d theta dt. And that is equal to the derivative of h, which is dh dt. All right. At this point, we now have all our variables to figure out what to plug in where. So we've got theta that we need, and that's given to us as pi/4. So that's at an instant. A kind reminder, you're not going to plug in that angle in the beginning, because if you do, you're saying that that angle is constant at pi/4. Now that we've taken a derivative, we can plug it in because it's at that instant that theta is pi/4 that we're interested in. So we've got pi/4 to plug in. We've also got that the rate at which the camera is tilting is in radians per minute. That would be d theta dt. So we're given d theta dt. So it turns out we've got everything we need here. Nothing we have to solve for. Sweet. So 0.14 radians, I'll call them rads per minute. And pi/4 is just in rads. So you don't really technically need units there. Let's just plug and chug. We'll solve for dh dt. So 500 secant squared of pi/4 times d theta dt is equal to dh dt, which is what we don't know. And I didn't plug in for d theta dt. Why wouldn't I do that? So let's plug in for d theta dt, which is 0.14. All right, sweet. So now from here, let's do out a little bit of math. Now, you could use a calculator here if you want to. It's completely up to you. But secant squared, that's the same as 1 over cosine squared of pi/4. Just a little bit of side math here, which is the same as 1 over, well, root 2 over 2, which simplifies, and that's squared. That simplifies to 1/2. 1 over 1/2, which is 2. Or you could use your calculator to find that. So all of this turns into 2 times 0.14 equals dh dt. And that's your final answer. So by the way, if you're taking the A, B, or BC exam, that's your final answer with units. So I've got my calculator here just off to the side. So I'm doing 500 times 2 times 0.14, which I should be able to do mentally, is 140. So that's 140. I'm realizing as I'm typing it in, I can do this math. 140, what are our units? We're rising the change in h over the change in time. So change in h would be in feet per, we got minutes, change in time. And that's it. That would be dh dt. A nice problem, very sweet. See you in the exercises. We got a lot to go over. Peace.